Hello explorers and welcome to another video. Today we're gonna talk about reverse engineering. This is the art of understanding things. So for instance, have you ever taken any electronic device and disassemble it in small parts just to figure out how it worked? Maybe you had some kind of a CD player or something when you are young, and you disassemble it in smaller parts to see how did the actual CD spin, or where did the different parts fit? Was it something that was moving inside of it? You can find a lot of different very interesting concepts if you just look into ordinary things and try to figure out how they work. And the same goes for code. If you want to know how a specific piece of software works, you can go into the actual source code and look at it, because much of the software we are using today is open source. But if you end up in a place where you don't have the source code, and perhaps you're not allowed to see the source code, and you're not allowed to actually disassemble the actual executable, then there might not be a good idea to do that. But if there is no restriction that you can't disassemble something, and if you don't do it in a malicious sense, you are just trying to understand how things work, then if you disassemble an executable, you will get something like this. So what we are seeing on screen here is some assembly code, and this is something that is disassembled. We can read that we have some byte here, 55, that is translated to a push operation. We have two other bytes, 31 D2 in hex, that is translated to XOR EDX EDX. And I happen to know, because I've done a bit of assembly before, that this operation will actually set EDX to 0, because if you XOR something with itself, you will unset all the bits. So this is what you will see, and it's not that easy to actually get a hang on what the code does and get a broader scope of what the code does. There are people that are coding just in assembly, but they often use a lot of documentation and a lot of extra comments just to keep track on all the things that they are writing. But if you have a good disassembler, you might get some C code, and that's what you see on your right hand side here, out from the disassembly, and you can perhaps get a little bit of a sense of what that piece of code does. But if you are lucky and you actually have the source code, you can learn even more. And today I wanted to look at some piece of source code that I have used, but I've not looked at the specific source code, so I don't know how it works. I just know how to use it, and I know the details about this project. This project we're going to look at today is the lit HTML. So when I'm going through and trying to figure out how things works, when I have the source code, I start by looking at the different files. So here in the repository, we can see that they have a lot of setup here. We have some documentation here. We have a good change log. That could be something to go into to see what functionality is in this application, and what can I look further into and try to find in the source code, because sometimes you don't know how things works and you might have missed some functionality, and then you can go in and see what has been added over time and get a sense of it there. Code of conduct is a very good thing to have, because then people know what to expect if you support this project and put in some code. And also contributing agreement is also in the same vein, so everybody knows how does this community work and how do I contribute to this project. Licensing file is also good to have to know which license this goes under. And we could look into that if we want, but I think there is a view that tells us up here that this is BSD 3 clause, so it's a quite open license. You can use this code as you like if you just give attribution and so on. And then we see here that they have a Travis file, so it is tested on Travis. We have some ignore files up here, some editing config, and they also use rollup, I see. And this is an npm package, it seems, so you have some package JSON, and then you have some configuration for linting TypeScript, and also a web component test framework down here, so a configuration for that. So you see just by looking at the root directory here that you have a lot of different functionality. And we can go into the package.json just to see what files are here. We see that they have added some files here. We have some test scripts. We should be able to find these kind of files in this, and the directories. And we can also see the license up here as well, and here we have all the scripts that you can use to test and format and also push and build this project. We see that the dev dependencies are quite few, but you don't have any dependencies out, so with just what this line here, you know that this is completely contained to this repository. We know that we don't have any other dependencies that could be a part of this project. It's just this project. But we have a lot of different dev dependencies to test this, so that it's well tested and has a lot of dev things that we can use here. So let's look into the tools directory here. Here we see that they also have a packaging, and this seems to be to package the documentation. I thought I saw something like that. There, this is to serve the site. So this might be some help to show the documentation for this. Custom typings. Okay, and let's see, in the source code here, we have the site and we have the serve site. So here we can see just a console log that the site is running, and then we have this site TS that has generate docs. Yeah, so this will generate the docs for you and show it on a site. So this is not the main source directory, so we will not look that closely to that. Another thing that we can see here, that they have actually a demo, so we can look into this clock.js demo to see a little bit how to use this. We see that we have some HTML element here that is extended. So HTML element is something that you use in your browser every day. So if you've written any web page, an HTML element is, for instance, the h1 tag or the paragraph tag or any of the HTML elements that you see on your page. All the tags are HTML elements. So we extend one of those and create our own clock. And we have some constructor here where we get a date after some interval, or in some interval. It's not a timeout, it's an interval, so we get a new date every second, and we attach a shadow. So this is let's see, shadow. This is a shadow DOM, so we have an open shadow DOM here. Then we have some render code here, a lot of CSS styling, and then we have the actual clock here, and we see we use a circle, we use some SVG, we have a square, and so on. And we have some invalidation and hour and minute ticks here. So this is a way to show a clock. And here we have this custom element, the lit clock with this function up here, this element. But where do we actually use lit HTML here? Let's see, we use render we use this HTML tag here. So from HTML, lit HTML, we use HTML, render, and SVG. So the render function comes from lit HTML. The return HTML tag here comes from that. And we also have some functionality to use SVGs inside of our template. So that was what I could glean from just this source code here. Okay, so we have the demo. Another way to know more about the project is, of course, looking at the documentation. So if you haven't used lit HTML before, you can read the documentation. The tests is a good way to see how the code works as well. So if we go in here, we see that we have a lot of different tests. So there is a lot of tests that you can look if you are wondering how a specific part is how it's working. And those should be in the lib directory. So we can find that here in the lib directory. So why is the tests? Okay, so the tests are running from here, but they are using the lib directory. Okay, so we are adding these modules in order to run our tests, and these are the test suites that we run. Aha! So we know that there are some functionality here. We have a lit HTML test as well. So we want to know more about the source code. So we have a test directory in here as well, in the source directory. And here we see this lit HTML test TS. And here we have even more tests. So what's the difference between the tests we had in the root directory and the tests that we have in the source directory? That's a good question. So I guess that all the functionality for this is inside of the lib directory, or lib and directives. We also have this lit HTML TS. So it can be that we have the pure functionality down here, and then we have added things in lib and directives, and then we have a polyfill for templating for browsers that don't have templating. So let's look into the main file here. We see that there are 24 people that have added things to this file. So it's a well visited file. So this is the module lit HTML. So let's see what we can glean from this. Okay, so it has a default template processor that it adds. We also take the template result for SVG and a normal template result from this lib directory here. We have the default template processor, both uppercase and lowercase, or capitalized or not capitalized. So I don't really know what that means. And we also have directive, and we have DOM parts for removing nodes and parent nodes, no charge, nothing in part from parts, no change, of course. Attribute committer part and attribute part, event part, a lot of things here. And we have render options. Yeah, so here we can glean that we have a lot of different things that we use in this main file here. But the actual main file does not have that much functionality. So that's interesting. So we export some constant here that has a template string array that takes a spreaded values of unknown and creates some template results using the strings and the values, and it's called HTML, I guess, and it's a default template processor. And we also have another for SVG. So that's the actual tag that we saw there. So this is a way to create a template literal. Okay, so we need to know more about the template result and the default template processor, because those are those things that is used to actually do this template literal here. So let's look into those. So those are in the default template processor and also the template result. So let's go back here, go into the lib directory and look at the default template processor. So this has a lot of different things as well. It implements a template processor. And here we handle attribute expressions. So if it's have a prefix of dot, then we will look at the committer, I guess. So this is perhaps not spelled correctly. I guess it should be like this, property committer. And we take the element, the name slice and strings to create a property committer. So that's for a property. And then if the prefix of any string things are an @ then we have some event part. So we will create event parts for those. And then we have some Boolean attribute part. If we have this question mark, and everything else is attribute committers. So those will be handled there. So these are to handle all the different attributes and their expression in the attributes. So we can either have a property, we can have an event, a Boolean part, or just a simple attribute. And then we have other nodes are handled by the text expression, and that will create a node part. So we perhaps need to look a little bit more at the node part. See what we can get from that. Let's see here. The node part is from parts. So let's go in and look at parts here. So parts have also a lot of different things here. Let's see if we can find the node part. Here we have the node part, and that's a part. So we don't know what a part is yet, but we know that a node part here. And we also have some comments here. A part that controls a location within a node tree, like range node part, has a start and an end location and can set and update the nodes between those locations. Node parts support several values, primitive nodes, template results, as well as arrays and iterables of those types. Okay, so here we have a node part. It has some options, some render options, and we append a start node and end node. So we create a marker for those in the container, and we insert after node. Then we will get the reference for the start node, and we will change the end node reference to the next sibling. Okay. So that's just to change. Start node is the actual node, and then we'll take the next sibling as an end node. So why do we change the marker if we add a node after? I would see that we only change the end node. And here we have append into part. So we have a node part, and then we will insert and create markers around those. Insert after part and set value, pending value, and commit. So it seems like if we just look at it at the large level, we have a node part where you can do a lot of different changes, and then you commit these changes here, and this will commit either a node or an iterable or a template result. Jesus, there is a lot of code here. But I think still that I think that I have gleaned a little bit more about how this works just by looking at some of these parts. I can't say that I understand exactly how a node part works, but we have seen some of the different parts that are more easier to grasp. For instance, this Boolean attribute part. We know that this will take something that starts with a question mark, and it will actually do some question about that expression. So we can either have a falsy expression, and then we'll, if the value is truthy, then the attribute is presented with the value of the empty string. If it's falsy, the attribute is removed. Okay, so we see here if the attribute should be a part of this. And here we see that we construct this. We say which element it has, it's connected to. We also have a name that we will save, and then we will have an array of read-only things that we can evaluate, I guess. And here we see that the length is not exactly equal to 2. We also see that string 0 isn't empty. Okay, so these strings that we get in here is some kind of an argument or some kind of an expression that should be exactly 2 parts, and the first and the second part of this expression should not be empty. So that we can glean from the first thing here. And then we can set a value. So let's see here. We have added strings. We have a pending value. Oh, that's unknown. So when we commit this, we look at the pending value, or if it's a directive, we will get that directive, we will append a no change function, and then we will execute that directive. And here we will check that if this already has a no change value, we will return. And then down here we will try to figure out what to put in this as a value. So we take the pending value and we not it. Is this to see that it should be truthy? No. But whatever this is, if we not it, then we can see that if it's truthful, it will continue to be true, and if it's false, it will continue to be false. But before this expression, it could have been any value, a value that is either truthy or falsy, but it doesn't exactly have to be true or false. So by doing this little operation here, we can see that it will become a Boolean. And then we will check that this is exactly the same, not exactly the same as the Boolean value we already have in the function. Okay. So I don't see that we set the value anywhere up here. So this can be null, I guess. And then we check if this value is true, then this element will have the empty string as an attribute. So we'll keep this Boolean attribute, but it will only be the empty string. So the attribute will be left there. Or we can remove this attribute by name if it's falsy, and then we set the value and we set the no change. So now we have looked at this Boolean attribute part. So I think I understand pretty much how it works. There are some parts that's still a little bit strange, and that's because I'm not familiar with this code. But I guess that by doing this and talking a little bit about the different parts that I understand as I see them, you can see at least a thought process when I read code and when I try to figure out how things work. And that's a very important skill when you are developing programs, because many times when you come to a new assignment at work, or you start to work with a new project, or you start to work with new colleagues, you will end up in a project where there already are code. And your first duty there, or the first assignment, will be to actually understand the code that you will modify later on. So the first thing that you need to do is some reverse engineering, go through, read the code. If it's well documented, you are very lucky. And if there are a lot of tests so you can see how the different things interact, then you have even more documentation that you can go through. But if you don't have any documentation, or perhaps even don't have any source code, then your work will be harder. It's not impossible, it's just harder. And the good thing, or the important thing, is to have the right mindset. You are trying to figure out how other people have written this code, because all code that you see online today are written by people or peers, and they have chosen to write in a specific style. They have chosen to write specific code for some reason, and sometimes code can evolve over time, so not even them, the people that actually wrote the code from the start, recognize the code anymore, because they have done so many changes that the code have been a little bit unreadable. Perhaps things are not really clear how it works and so on, and that's just because you have went through it and fixed bugs on bugs and bugs and bugs, and perhaps the involved code is very sophisticated. It has a lot of value in it and a lot of history, and changing it can be hard, but it can also be something that will introduce new bugs. So a good skill to have is to reverse engineer code, figure out what it does and why it's written that way. And sometimes you can understand something completely, sometimes you can just grasp small parts, but the important part is to understand. So if I would give this project a couple of hours, I maybe understand the most important parts of this project. But I think I will need a lot of time, experience, and perhaps I need to do some changes to the code and be a part of this community, talk to the developers and so on to understand it fully. So I hope that you found this video interesting. I hope that you learned something today. If you haven't subscribed yet, please do that. If you have any good experience or bad experience about reverse engineering code or trying to figure out how something works, please leave them in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.